People don't really know this, but the beginning of Kahneman and Tversky, the beginning of behavioral economics and judgment decision-making, actually started with a very simple premise. And the premise was that people are just very, very bad with statistics. So they've tried to show this in many different ways. We've already seen. So the first study that Kahneman and Tversky ever did in the 1970s was to go to statistician conferences and give them an example of a very small sample experiment, 20 in this condition, 20 in this condition, and then showing them the result, and then asking them, what is the likelihood that this is going to replicate? If you recall, a few sessions back, we talked about some of the issues with Kahneman and how he fell into this trap of alerting the world about this problem, but then actually following this with the primary literature and putting a whole chapter in his book about primary literature as something that works, when all the research in priming is based on small samples. So this is actually how Kahneman and Tversky started this whole thing with judgment and decision-making. But once they understood that statisticians and scholars, researchers, academics, professors get statistics wrong, they wanted to see how far does this go. It's not only that we don't really understand issues of power, of how large the sample is, there's all sorts of other things. And the brilliancy of Kahneman and Tversky, and this relates to your third task, is being able to capture something that might go wrong in a single question. So Kahneman called this the psychology of single questions. So within one question, just by framing something in a certain way, you're able to demonstrate a problem. If you remember, in one of the sessions, we had two types of companies. One type of company has very familiar brand names, let's say Starbucks or Reebok and all that. And another had unfamiliar names, something that was called a group or international. And people were asked, what is the likelihood that these companies are bigger or more well-known? And people just use the heuristics of availability. It's easier for us to recall Starbucks, easier for us to recall Reebok. Therefore, we say they're likely to be the bigger companies. However, in that specific example, it's very easy to Google things up and see that the bigger companies are actually the ones that are the groups that own the different brands. So that was an example for a single question where most people kind of misalign and go into the wrong option. I will show you a few more of those. They're a little bit more complicated, but they still capture things within a single question. So everything started in the 1970s. So after they've demonstrated this on statisticians in statistician conferences and alerted the world that we don't know how to evaluate the credibility of scientific evidence, they went on further to try and establish why is this happening. And their main insight, which was only took Kahneman up until 2011 to really come out with this system 1, system 2. This concept that we have these two minds, this is only symbolic. There are no real two minds in our brain, but there's one that is very intuitive, gut reaction. When we see something, we react very emotionally. Then we have the slower, more deliberative, more analytical one that sometimes is being activated in order to come and check what happens with the gut reaction. So the classic example is, I don't know if you have a driver's license already or not, but once you start driving, you'll see that it takes a little bit, when you do your first lessons or when you come to the driving test, you feel very awkward about this because driving is not something that we do a lot. But over time, the more that you drive, the more it becomes something that's automated. So a lot of people that have been driving for many, many years do this on automatic. Sometimes they don't even notice the kinds of things that they do because everything becomes second nature. So then something after becoming habitual can become almost automatic. We process a lot of things in our vision. We process a lot of things in our audio. Our body takes care of a lot of things without us noticing this. If we had to analyze each and every step about us breathing, about us seeing, about us hearing, then the body would not function. So we need these two different systems. But the problem is that if we activate only the analytical, only the gut reaction, the emotional, the instinctive system, then we might fall prey for some of these biases. So their main claim is statistics are a problem because statistics require the system too. They require a little bit more processing. They require you to really sit and think about the problem because if you use your gut intuitions, you're likely to go wrong. And they have some amazing examples for that. Also, people are very short on time and in patience. So typically when they come across statistics, and I remember this very well, especially as a student, they try to take shortcuts in order to try and arrive at the right conclusion within the shortest amount of time. So in order to do that, they tend to follow their intuitions. So there's different kinds of processing. Sometimes it's okay to follow your gut intuition. So for example, if you've driven for a very long time, it's good for you to follow your intuition about how to drive. If you would have to think about each and every step of the way and everything would be just like driving the first day, it would be a big problem. And then if we use our experience, then it allows us to save a lot of time and we don't have to think about everything. Then rationally, the more slow, careful, deliberative process, so we differentiate between experience and heuristics, and rationally comes into play whenever there's a problem. For example, if you're driving and you encounter some new situation, something that you haven't seen before, then you need to switch into the more slow, deliberative in order to try and assess what you should do. So for example, you've taken a wrong turn and now you need to correct for that. You followed the advice of Google Map, but it took you to the wrong direction. You inserted something, how somebody is calling you. So then you need to make a decision of what you should do. Maybe you should pull aside and then answer the phone. Maybe you should put in new directions to the Google Map. So these new situations require you to move into a different kind of analytical mode. So here's the first question for you. So I think you're familiar with this. Perhaps you've seen this before. It appears in every basic statistics book, but I think a lot of us get this wrong. So if we take 23 random people, so you can even think of this classroom, what is the probability that two people have birthdays on the same date, except for February 29th, which is relatively rare? So if you think about this and you think about this number, then something intuitively comes to mind. So I'll invite you to take part in what Kahneman and Tversky suggested to the world. This existed long before Tversky and Kahneman, but they used this in order to show something. So just try and estimate. If you know the answer already, because this is something that you've looked up already, then no need to answer. But if you're using your gut intuition, then I would really like to know, as the average of this classroom, what is the gut intuition about the probability of two people in a class of 23 having the same kind of birthday? I'll give you some time to think about this. Yeah. So you can already see the different kind of responses that people usually have for this kind of thing. There's the intuitive heuristic response, there's the experienced response, and then there's the rational response. Actually, this is a statistical question that can be calculated. However, it takes time. We need to first understand how to calculate this. So what is exactly the equation that we need to put in? What are the numbers that we need to calculate? This seems effortful. Therefore, we use this heuristic response. And typically, people just replace this with a simpler question. Do I know people who have the same birthday on the same day? And typically, the answer for that is no. Hence, probability is small. So already you can see that perhaps, based on our experience in this class, is that if I give you a gut intuition response that is easy, it is probably the wrong one. So this response, the heuristic response, is not good. The intuitive experience response is, there is a problem here that requires some effort and it requires a special kind of statistics. Therefore, you should be very, very careful. Therefore, you might want to switch to the more effortful one here. So if we just look at the responses, so people estimate this to be at 33.6. As you can see, the distribution is very, very high. Some of you put this somewhere in the middle. Most of you put this under the middle. Then we have some extreme responses here, close to 75 or 60. So it seems like a big range. And some of you even say that the probability is very, very small, right? Who knows the right answer? Who is sure that they know the right answer based on experience? We can share with us. Okay. So actually, this is the chance. It's about a 50% chance. So we're four of you that were very, very close to the actual answer. But as a class, we failed. But I should say we failed a lot better than most of the other classes, because many classes and many workshops that I give actually estimate this is very, very low, 10% and below. So actually, we're doing better than them. And there's a way to calculate this. So this is the equations that you need to do. So no matching birthdays is 3064 out of 3065. So it's 99%. And then the number of comparisons. So you do this, it's 253. And then you basically raise this by 253, this by this, and then you find it's 49.952. No matching birthdays, and then you deduct that from 100%, and you get to a 50.048% chance. So intuitively, it seems like we expect something very, very small, but it seems like we don't know anybody who has the same birthday as us. It's difficult to think about somebody from a previous experience. Therefore, we just assume. But if you just sit down and calculate this, it seems like it's a quite high probability, about 50%. Is the example clear? Do you have any questions about this? Clear? Okay. So now that you've gained a little bit of experience and now you know how these things work, here's another one. So I'll move this to the other one. Oh, people already started answering. That's nice. So this is the question that they gave. Fold Saturday's edition of a newspaper. They used to have newspapers with actual paper, you know. We don't see this a lot nowadays, but let's assume that there's a newspaper and it's like 1 centimeter thick. If you take that and you fold it one time and then again and again and again and again, how many times do you need to fold it in order for this to reach the moon? So you fold it, becomes thicker, you fold it again, becomes thicker. So the original one is 1 centimeter. How many times do you need to fold it in order for this to get to the moon? Now, this resembles a very important question that we had during the pandemic. During the pandemic, most people did not understand the problem of, so what happens? So why is this so important that I social distance, that I don't meet other people? And the problem with this is that we have something called exponential growth. So whenever there's even a single case that is infectious, and that person meets 2 other people, these 2 people become 4 people, these 4 people become, very fast, this grows and becomes exponential. So you might have some gut reaction saying, from here to the moon, just seems like this is a very, very large distance. We don't get to the moon very often. We look at this from afar, it looks very small, right? So it seems like it's a very large distance. Even if you look at, from here to the sun, how many times more do you need to fold it for this to get to the sun? So it seems like something that we would need to fold again and again, many, many, many times. So sometimes people say very large numbers, but what is the actual number? Okay. So we've got a lot of estimates here. So 35, 40, 100 times, 10,000 times. Yeah, these are relatively good guesses. I would say that generally in an uneducated sample, most of the responses are somewhere around here. So it just seems, oh, the moon has to be a very large number, 10,000 times. Some people go even further than 10,000. It seems to be on the higher end. But it seems like you know something about exponential growth. So you might understand this a little bit better. Here again, you can differentiate this between the experience, the heuristics, and the demanding. And the demanding one is you just need to sit down and solve the problem. If you're experienced with this, you know, oh, exponential growth. Okay, I need to be very careful about this. I need to switch into calculating this. But the heuristic response is, okay, the moon is very far. Therefore, you need to fold this again and again many times. So you only need to fold a newspaper 35 times in order to, 36 times in order to get to the moon, which is very surprising. It's almost counterintuitive. You've been able to know this, perhaps based on your experience, perhaps based on understanding that this is a very difficult problem and you actually need to calculate this. So if you need to go further, so let's say in order to get, so for the moon, it was 36. How much would it be for the sun in order to get to the sun? How many more times do we need to fold? From the sun to the moon, there's a lot more than just from Earth to the moon, right? Yeah. So if you go on Wikipedia, there's like a lot of numbers jotted down in there, and you can see what exponential growth is. And the problem is that most people just don't understand exponential growth. So this is actually not as thick as 1 centimeter. This is a finer paper of 0.1. This is the example from Wikipedia. So you can see here like 0, 1, 2, 3. So already here, at the beginning, it seems to go very slow, but already here at 17, we get to a height of 2-story house. 20, we get to the Sears Tower, which is a big tower in New York. And then finally, in order to get to the sun, we need to fold this 50 times. So counterintuitive. Sometimes when I show this to people, they're just like, no, something is wrong about this. Somebody should check Wikipedia. This doesn't make a lot of sense. Because we are not very good at statistics. We just don't know how to measure these things very well. So sometimes what we need to do is to refer to experts who have this experience, statisticians who know what they're doing. But even then, you need to be very careful because even statisticians, even scientists sometimes make mistakes. What I like about this is that almost every folk culture, including China and India, have some story about how this backfired. And I like this very interesting story about the beggar and the king. So they play chess with each other. And then the king offers a small fortune for a win. Beggar declines and asks instead for a different paradigm. He asks to double the amount of rice for each square on the chessboard. So the king says, oh, just a grain of rice for each one on the So doubling for each one of the squares on the chessboard, you've got a 8 by 8, so you've got like 64. It doesn't seem like this is a lot. So he agreed to this, not thinking very clearly about what are the implications. So the beggar knows math, the king just uses gut intuition, and then things go very, very wrong. If there's only 64 squares, like how many grains can this be? And the problem is that if you look at this, this is the very big number, and there are not enough rice grains in the world, definitely not in China, but generally this is a very, very big number. So the king will go bankrupt. There's lots of things that you can learn from this. So if you're a policymaker, you need to engage with the public. So for example, when there's a pandemic, you really need to explain to people what is exponential growth and why this is a big risk and why even one person who's not social distancing can create a big problem for the entire society. So just a lot of things that we need to take into consideration. And sometimes it's very easy to demonstrate this to people by using videos like that. So instead of telling them, okay, let's learn statistics together, this is how you do math, and this is what the problem is, most people will not understand this. So coming out with some of these videos can help people do better in order to learn the implications of what it is that they do. So I just want to say that all of these examples have been taken from these two books. So we've already talked about Thinking Fast and Slow, but there's also the Improbability Principle by Devin Han that is very useful for these kind of things if you want to see more. Okay, here's another example from Kahneman and Tversky. So this is the next question on the Mentimeter. A certain town is served by 2 hospitals. In the larger hospital, about 45 babies are born each day. In the smaller hospital, about 15 babies are born each day. So just a lot more babies are born each day in the hospital, 3 times more, right? We know that on average, we're about 50-50 boys and girls. So of course, depending on which region of the world, we're 50% overall. However, the exact percentage varies from day to day. Sometimes it might be higher than 50%, sometimes lower. For a period of 1 year, each hospital recorded the days on which there were more than 60% of the babies born were boys. Which hospital do you think recorded more such days? So the statistics that we have here are very straightforward. We have a 50-50 boy and girl, right? And we have a large hospital that has 45 births. And then we have the small hospital that have 15 births every day. And then they record this for an entire year. And they want to know how many days, which one recorded more days, where there was more than 60% that were boys. Okay. So think about this. Try to think, what is your intuitive gut reaction? Then because now you're experienced and you understand, oh, maybe my gut reaction is wrong. Therefore, perhaps I need to calculate something, or I need to think about this very, very carefully. And perhaps there's a catch here. What should I do? I'll try to shift into the more effortful mode, but there's something here that I don't understand. What should I do? Okay. So I'll give you a moment to think about this. What's the best way to approach this question? What is the most important thing that we have here, the most important data that we have here? Should it matter how many babies are born every day in the hospital? Why would that statistic matter? Is it just to distract us, or does it give us some information? What to do here? Yeah, very good. Yeah, can you say a little bit more about that?
Yes, it's just like what I know, it's like not generalizable. So something can happen in a small sample that typically would happen in a larger sample.
Yeah, very good. Right, in the population. So both of these. So when we have a sampling, sometimes we want to understand how representative this is of the population. The population here is 50-50, right? However, the sampling is very, very different. In a small hospital, we have small sampling, but then there's a very wide range of error, right? It could go in, there's unexpected things that can go. So it's very wide. It can go up, it can go down, right? But the larger the sample is, the smaller the error, right? The more you get to the actual population. So it's a very good point, and it relates to the point that we said about priming and small samples, is that we cannot generalize from small samples because they can go up, they can go down, it could be really a fluke. The larger the samples that we have, the more solid it is and the more it represents the population. So this is about sampling. Now, the gut intuition would be, oh, this shouldn't matter, right? Both of them should be about the same because it's 50-50, right? Why would it matter if this is a large hospital or a small hospital? And honestly, the first time that I saw this, even though it was during my PhD, I said, yeah, it's about the same. But it's a good thing to realize that there's a catch here. And it has something to do with the sampling. It has something to do with when we have a very small sample, weird things can happen, right? So sometimes we can use a little bit of our experience in order to think, so what happens when we have a small sample compared to a larger sample? Now, we understand that small samples can go in all kinds of different directions. So yeah, smaller hospital has a wider chance. So 10 of you got this correctly. About the same is what I did when I was in my PhD and saw this for the first time. So a lot of people get this wrong. Yeah. So it is the smaller hospital, and here you can see kind of like a demonstration of this. So you can see that the smaller hospital, generally the red ones just go into far more extreme. And if we'll have another hospital that has 100 babies, then you'll see that it even goes, the confidence intervals or the error rate will narrow even further, so that it will be much closer to the entire population. So you can see the expected values, and Kahneman and Tversky were able to show that both for very experienced people, like PhD students, like scholars, even statisticians, people can get this very, very wrong. Now, I honestly was a little bit skeptical of this. So I wanted to see whether this really works or not. And the nice thing is that throughout my work here, teaching courses, I've done a lot of replications with you, with HKU students that took this course, Judgment Decision Making or Advanced Social Psychology, and with thesis students. And one of the things that we did is actually we revisited a lot of the problems from Kahneman and Tversky in 1972. What's weird about this is that actually nobody has done this in the past 40, 50 years. Nobody took all of the problems that they wrote about in that paper and just tried to replicate again with a layperson sample. So we did this, and you can see here, this is Danny 1, Kai-Hin 1, who did this for his thesis. And this is one of the many different examples that we gave people. So people were trying to rate a lot of these different statistical questions. And finally, we were able to find very large support for this. So for example, here, you can say that most people say about the same. Most people say about the same. We also manipulated something that Kahneman and Tversky manipulated. But generally, you can say that most people got the wrong answer. And there was no actual difference between how many people said large hospital and small hospital. So it almost seems like they were guessing. So the numbers here, about the same, is like the highest, the most frequently chosen thing. So we calculated this. So I think there were 13 different problems, and out of those, 12 out of the 13 replicated very, very well. So 50 years later, after this original one came out, we were able to replicate this here at HKU with an HKU student in undergrad, and then finally published this in an article in a journal. So it's nice. The way that I know, and the reason why I show you these things, is not because I saw this on a TED Talk. It's not because I heard about this in an episode. It's not because it's in some book chapter. So almost everything that I show you, it's because I actually try to run this on a sample. And the way that we do this is that we do a pre-registration. We do this on very well-powered samples in order to really try and get to what works and what doesn't work. In the one scenario that didn't work, then we try to figure out what actually happened there. Why didn't it work? And another thing is that if you go and you read this article, we also wanted to do something that Kahneman and Tversky didn't do. So we went further than this. We wanted to see if somebody gets one question wrong, does it get the other questions wrong? Is there some consistency between the different problems? So what's nice about this kind of thing of doing replications of all these problems together with one sample is that you can start to see different patterns, whether people really fall into these things consistently or not. So that's just a good work by Danny 1. In addition to this, we also had another question. I'll give you an example of another question. I don't know if you can see this, but I'll read this out to you. It goes like this. All families of 6 children in a city were surveyed. In 72 families, the exact order of births of boys and girls was girl, boy, boy, girl. Okay, so 72 families, 6 children, this is the pattern. What is your estimate of the number of families surveyed in which the exact order of births was boy, girl, boy, 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 girl, 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 boy, boy, girl, boy, girl. So look at these patterns and try and think, what did Kahneman and Tversky try to do this? So put on your scientist hat and try to understand what could be the fallacy that they're looking at over here. What are they trying to do? So what would most people answer? What is special about the first pattern? Boy, girl, boy, 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 boy. What is interesting about this pattern? Yes, please.
Like it's very time.
Yeah, why rare?
Because the pattern is just random.
Yeah, so the third pattern is more likely, more random, right? Yeah. So out of the 3, which would you expect to have the highest number? The third one? Okay. Yeah. How about the first 2 patterns? What differentiates between them?
I think maybe the first one will have a smaller number because they are small bodies.
Yeah, right. Yeah. So we know generally that in the population, there's 50-50. So perhaps people think, oh, if it deviates from 50-50, perhaps there's smaller likelihood of that, right? Something like that. In the second one, you already identified something else. There's a pattern here that does not seem random. Boy, 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 girl, girl, girl. This does not seem like a random sample. Then perhaps this is less likely, right? But if we have something that seems completely random, like girl, boy, boy, girl, and also has 50% chance, that seems to be the most likely, right? Okay, so very good predictions and very good hypothesis. And this is the hypothesis that Kahneman and Tversky had back then. What do people actually say here? Go back to this. So we were able to successfully replicate this. So their hypothesis here, I'll just show here. Sample with boy-girl split closer to the equal 50-50 split is perceived as more probable than the lesser equal, right? So this is very close to what you said. So if it's closer to a 50-50, people perceive this to be more likely. But actually, in reality, all of these are as likely. All these patterns are exactly the same, right? So if you have 72 families with that kind of pattern, you're likely to have something around 72 families for each one of the other patterns. So we were able to see support for 1A. What is 1B? It has to do with the randomness. So it seems like the random pattern is perceived to be more probable than a sample with an orderly sequence. So when the sequence seems too unnatural, it seems too orderly, too organized, people say it's less likely. So very simple statistics, very simple heuristics. I think most of you got this correctly when you put all of them in the 72. Yeah, but a lot of people get this wrong. So next time you go to a lab meeting, pose this to your professor, ask them what the right answer is. I think you'll be surprised just how many people get this wrong. What is also nice about this is that you'll see that we've done this with many different problems. So we won't go into this, but you can see some of the problems have to do with this boy-girl. Some of them have to do with the large hospital or small hospitals. You can see that the orange one is the heuristic, the representative heuristic response. So a lot of people just answer based on their heuristics and not based on what actually statistics are. So a lot of people got this very, very wrong. So it's a very successful replication of Kahneman and Tversky. We only got one wrong, unsuccessful, and we contemplate in all sorts of different ways. All right, before we move to this, I'll give you a 5-minute break, come back, and then we'll do a bunch of other questions. No more statistics. Now we're looking at how we spend money and how we think about money and ownership. Okay, 5-minute break. Because Veritasium is very good at communicating these things, and he shows this in a very entertaining way. So perhaps you've heard about some of these problems that he's going to show. I think what's interesting about this is just how quickly people respond to very simple questions. So once again, it's the psychology of a single question. And then almost immediately after they answer, they realize something very, very badly. Something went very badly. So here it goes with Veritasium.
For most of us, thinking is at least somewhat unpleasant. We try to avoid it where possible. For example, I asked these guys, how long does it take for the Earth to go around the sun?
What do you reckon, cuz?
Is it 24 hours?
Obviously a day, yes.
Or take this problem, which has been given to thousands of college students. You go into a toy store, and there's a toy bat and a toy ball. Together they cost $1.10. And the bat costs $1 more than the ball. How much does the ball cost?
10 cents.
We're all wrong, aren't we?
What's the answer?
If you think about it for just a second, it's obvious that the ball can't cost 10 cents, because if it did, then the bat would cost $1.10 and the two items together would cost $1.20. The correct answer is 5 cents. Now the point of these questions is not that they're difficult. Any of these people could have quickly checked their answer if they wanted to. The point is that they don't check, because thinking is uncomfortable. It takes effort.
Hey, the Earth doesn't take one day to get around the sun. It takes like a year.
Now I think it would be easy to put these mistakes down to stupidity and believe that you, being much smarter, could never fall into such traps. But then I think you'd be fooling yourself. I think these examples reveal blind spots in all of our thinking due to the fundamental way that our brains work.
Okay, I'm going to stop here. It's going to go into system 1, system 2. By the way, it's an anecdote. Many people don't remember what 1 stands for and what 2 stands for. I think it's just a very bad naming, and it's a little bit ironic that somebody like Danny Kahneman called something system 1 and system 2 instead of calling them system fast or system slow or something like that. Like, why would you have to remember what is 1 and what is 2? I think another stupid mistake statisticians do is type 1 error and type 2 error. Nobody remembers which error is what kind of type, right? So just naming is very important. So get naming right. So even people like Kahneman, who should know better, didn't get this very Didn't do this very well. Let's go back to this. So we've done that. Okay. So now I'm going to ask you, I thought instead of giving you handouts, I'm just going to ask you to open this on your laptops or on your mobiles. So you can scan this if you want, or you can go to mgto.org/JDM week 6, right? And I'm asking you to only open this once, please. Okay. And it will give you a Dropbox of a file. So please download that file, open this on your laptop. And I will give you a few minutes in order to go through those questions, okay? All right, so you'll see in the handouts, we'll do this together. First, I'll give you some time in order to answer these questions. And then together, I'll ask you to put stuff on the Mentimeter in accordance with what it is that you answered. I should already tell you that just like in the previous time that we had handouts, there are two versions here. So there's version A and there's version B, okay? So it's very important that you look at your document and you see what letter is on top, A or B. And version A is different from version B, okay? Don't open this again. I will give you both versions, but it is important that you understand that this is what's called a between subject design. So here it's no longer a single question. Here, we're manipulating something. So as you answer these questions, please put your scientist hat on and try to guess, what is this about? What could be happening in the other condition? What are they trying to measure or manipulate here? And we'll work on these things together, okay? Then here you have the title of the article for the first 3 questions. So you can already think about your condition. What is your condition and what the other condition might be? And this is called Less is Better, classic article by Christopher Shee from 1998. And Anna here and Stephanie did a replication of this. I think it was the first year that we did replications when I came in, 2018. That was one of our first ones. Everybody finished? Everything okay? Yeah? Okay, terrific. So what Christopher was trying to do here was to come up with some examples where actually less might be perceived to be better. So what are the 2 different options that we had? So you saw different versions. And in this specific case, one of the 2 versions that you saw was some of you saw a condition with a scarf. And the scarf costs somewhere between 0 and 50. And your friend bought you a scarf that costs $45 US dollars. And then we've got a coat, and a coat ranges from $50 US dollars to $500 US dollars. But your friend bought you a coat that costs $55. The question is, which one of the 2 friends is more generous? How is this gift going to be received? So what Christopher Shee was trying to show is that if we have a between subject design where you only see one of the conditions, you will answer a certain way. But if you see both conditions together, it will immediately become apparent that there is a problem here. So if you see both of them together, which one is the more generous friend, the $55 US dollars or the $45 US dollars? There's no question about that. Because the person who spent $55 US dollars spent more money than the person who spent $45. However, we are a reference machine. We always look at reference points and we always make all kinds of comparisons. So some of you only saw this range, 5 to 50, and you thought, oh, 45 out of the 50 maximum, that seems very generous. Even if it's just a scarf. The other one, like you got a coat. The coat is worth more money. It's a more substantial gift than a scarf. But the people who are in this condition only saw the range 50 to 500, and then they saw that the friend only spent $55 US dollars, right? So what they were trying to demonstrate is that when people are only assigned to their own condition and they don't see the other condition, then people from the scarf will say that their friend was very generous, and people with the coat will say that the friend was not very generous, right? What happened in the second one? The second one, we had 2 types of ice cream. So you can see what the ice creams look like next to each other. You saw one of the 2 types of ice cream. So actually, when it comes down to how much ice cream there is, it does seem like there's more over here than here. So you've got 8 ounce compared to 7 ounce, right? But it does, when people just compare this to how big the cup is, it seems like the left one did not fill up the whole cup. So it just gave you 8 out of the 10. And on the right one, they overfilled the cup, right? Giving you more than what the cup actually holds, right? So 7 when the cup is only supposed to hold 5, right? So the question is, how much are you willing to pay for that? So if you see both of them together, it becomes immediately apparent that you're willing to pay more for the left one because you get more ice cream for that, right? But when people have a between subject design and they're only assigned to one of the conditions and they cannot see the other condition, then they're willing to pay more for the overflown cup of ice cream, even though it's less ice cream. Okay, is that clear? What happened in the third one? Third one is kind of interesting. So I'll just zoom into this. You saw one of these two conditions. They have exactly the same for dinner plates, soup salad bowls, and dessert plates. They'll have 8, all in good condition. But in addition to that, in one of the conditions for set A, you also received some cups and some saucers, but some of them are broken, right? So you have 6 that work, 2 that are broken, 8 that work, 7 that are broken for the saucer. It does seem like you get more in set A over set B. However, just by having things that are broken in the set, people evaluate those as being of lower value. If you see both of them together, you say, okay, so what if some are broken, but I also get some ones that are not broken, therefore I will value this as higher, right? Some people might say, perhaps the broken actually shows something about the quality, therefore I will decrease all of these together. But Christopher Shee was actually saying, here you get more. So from the economist perspective, you would go for this if you see both of them together. But if you don't see both of them together, you will actually go for the one that less is better. So this kind of thing. So you see that here we've got Anna and Stephanie and 2 other students. So both of them, we ran this together with 2 groups that evaluate each other and submitted this together. And what you can see here is that generally we found very strong support for all of these together. So study 1, study 2, study 4, which is the ones that I just gave you, that found these effects. Actually, some of them we found larger effects, some of them a bit smaller effects, but across all of these different studies, we found support for Shee's findings. So we compared the joint evaluation to separate evaluation, both of them together compared to a between subject design. And we were able to see the differences that less is better. We also added some extensions. This is about how expensive this is or about generosity. And then we saw similar effects. What's nice about this is that, as you can see over here, the effects are quite strong. So when you have a Cohen's d of 191, this is very rare. So for me to be able to run a well-powered pre-registered application and to find effects like this over classics is very encouraging. This seems to me that this is a very solid finding. Okay. What are some of the takeaways from this finding? Let's assume that this works and that this is reliable and that this is credible and that this really happened. What are some of the takeaways that we can have? Let's say that we're policymakers or we're marketers or we want to do something with this kind of finding. What can we do? But generally, and there's something very encouraging about this, it's not so much about how much money you spend, right? But it's more about how you spend it. So if you spend this in a clever way, you can actually get your friends to be more appreciative or to think of you as a more generous person. Here, there's a very simple trick. And the trick is, I think what you were trying to describe, is that if you select something that is on the higher point of a lower range, so in this case, it's a scarf. It's a very good scarf, but the scarf is on the lower range of 0 to 50, right? It would be more appreciated than if you buy somebody a coat, which is on the lower end of a higher range, right? From 50 to 500. So you need to think about this, not only how much money you're spending on this, but how it relates to the entire category in which this is in. This has a wide array of applications. So one of the interesting things would be to try and see, for example, if I would want to see other examples for this, then I would go look up Christopher Shee, 1998, and see all the other implementations that I have done. Actually, a lot of policy and marketing is very, very good at this, right? When they want to sell you something and they want to make sure that you put more money into something, right? Then they manipulate the reference points. They try to make you compare this to something else in order to get you to evaluate this to be higher than it actually is. Okay? So in the wine, we have these 2 versions. Let's see the 2 versions. Imagine that a decade ago, you purchased a case of good wine. Now, considering that you purchased the wine for $5 per bottle a decade ago, how much would you be willing to sell the bottle per bottle now in the US dollar? And version B is, instead of you purchased it, a wine merchant purchased that case of good wine. Now, considering that the merchant purchased this wine for $5, how much would you be willing to buy it per bottle now? So This is one of the classics. Richard Thaler, when he received the Nobel Prize, this is one of the examples. So there's something about ownership. And we're trying to make it's called the endowment effect. So just by owning something, you're already feeling a little bit connected to it, and you're requiring more money in order to sell it to somebody else. And it's not the same kind of evaluation as if you're going to buy this from somebody else who has that. So if we look at this evaluation here with sellers and buyers, so sellers generally, and here this is a successful application, demand something like 3 to 4 times more what it is that they're willing to pay for something. So $5 grow to $27 if you're a buyer, and $5 grow to $90 if you're the seller. Classic effect has been shown many, many times. One of the things that have been repeated again and again over time, I won't go into rationality cards, but I'll show you the endowment effect. There's this video by somebody called Adam Grant.
Would you sell your lottery ticket for twice what you paid for it, or would you be too worried that you were already holding the winning ticket?
This is Why Are We All So Stupid?
The show that explores the cognitive biases that lead us to make irrational decisions.
I'm Sarah Silverstein.
And I'm Adam Grant. The endowment effect is about what happens when you own something and how much more you value it than you would have if it didn't belong to you. When you own something, you start to identify with it, and you take it a little bit into your sense of who you are. And so if you're going to part with this, if you're going to give it up and lose it, well, now you really have to, you have to pay me to give away a tiny piece of my identity.
We went out on the streets of New York to try to buy people's lottery tickets for more than what they paid. How much did you spend on it?
Only $1.
Could I buy it from you for $2?
No, I'm trying to win. I feel lucky. $2 is not a profit.
Could I buy them from you for $4?
Why?
Would you sell me your lottery tickets for twice what you paid for them?
No.
Would you let me buy it from you for $24?
No.
Can I buy it from you for $10?
Sure.
Can I buy it from you for $2?
No.
Why not?
It might be my luck.
What? But you can buy 2 tickets.
No. I just want to keep it. Maybe I'm going to be the winner. I think this is the one.
$5.
Here, thank you.
$5. You got it.
Nope. Because I have
Really?
a better chance to win.
I'm willing to negotiate to $6.
Okay.
Yeah?
Yeah.
Okay.
I guess we buy the same ticket because
Okay, well then you'll have to split the winnings with me if it's the same numbers. This is not the first time we've done this, but the results are always the same. Would you be willing to sell me your tickets?
For less than I bought it?
For more than you bought it. Would you be willing to sell me your ticket?
No, I'm not.
For $12?
No.
For $20?
No.
You haven't even heard my offer yet.
What if I end? You have $700 million?
Would you sell me your ticket?
No, I will not.
Would you be willing to sell that ticket to me?
No.
Can I buy it from you?
No.
For $4?
Yes.
Yes?
Yes.
Deal.
All right.
Wait, do you want to take a picture of it first so you know if you sold the winning ticket?
Yeah?
Yeah.
Yeah.
You should.
That's going to be horrible.
Could I buy it from you for 4?
No.
For 8?
No.
You haven't even looked at the numbers.
So I think the question with that person over there, over regret, has a lot to do with what this effect is about loss aversion. So people don't want to later find out. So he's very it's atypical in that he wants to know, but most people have regret aversion. They don't want to know whether this was the winning ticket or not. Just want to gain the profit from this. But it's quite amazing to see just how much more people are demanding in order to sell that ticket to somebody else.
You could keep $10 and buy $20 more.
They're random picks, and I'm going to take my shot. You got to be in it to win it.
I offered to buy people's lottery tickets for multiples of what they paid, usually starting with 2 times what they paid, but going as high as 8 times. 78% of people refuse to sell me their tickets. So why are we all so stupid?
Yeah, very bad name for a video series. Why are we all so stupid? Because this is not stupidity. And I think this is how people sometimes understand heuristics and biases. I really wish Adam Grant would know better than to call this why are we all so stupid. But they are trying to explain why this is happening. And it does have something to do with loss aversion.
When you own something, it takes on this sort of extra value to you and you don't want to part with it. And lottery tickets are especially dangerous this way because we're all superstitious. And imagine that, I paid $1 for my lottery ticket, you want to buy it for $2. I know it's a small chance, but I will regret it for the rest of my life if I sell my $1 billion lottery ticket to you for $2. I think that, you'd see people a little more willing to part with something that had less of an extreme payout. But even then, when people, own something, even if they didn't choose it, if it's given to them, they start to become attached to it and they're a little bit more reluctant to let it go.
And where do we see this in our real lives?
You see the
Okay, I'm going to stop here because we need to move on. I'll just say that one of the first replications that I ever ran has to do with the mere ownership effect, which is related to the endowment effect. So we ran this and finally published this together. So these are my students in Maastricht University, and we found very, very similar findings. In addition to this, we also ran a meta-analysis. So not only did we do a replication to make sure that this is replicable, but we also did a meta-analysis in order to examine throughout the entire literature what is the effect. And as you can see here, it's highlighted over here, that the effect is quite strong, 0.57. We did not find very strong indications for publication bias, so we ensured that it's not because of people submitting their null results and not getting in. So it does seem, even though there's not a lot of studies that we found on psychological ownership, found like 26 samples, but it does seem like this is quite stable with 3,000 participants from these 26 samples with quite a large effect size. So when we see a Cohen's D or a Hedges G, which is about the same, of 0.57, we consider this to be a large effect. So if I want to know if something is credible, aside from just doing replications, well-powered pre-registered replications or registered reports, one other way that I do is run meta-analysis in order to see the entire literature altogether. So very, very interesting effect that is very solid, and this is one of the first projects that we ever did together. This is Richard Thaler, and this has to do with mental accounting. All right, so we have two versions, version A and version B. So in the version A, you arrived at the cinema to watch a movie that costs 200 Hong Kong dollars. That's a very expensive movie, but let's assume that this is a VIP movie. When you arrive at the cinema, you find that $200 Hong Kong dollars are falling out of your pocket. Will you buy a ticket for 200 Hong Kong dollars? And people usually look at version A, they say, what do you mean? What does this have to do with, so some money fell, how does this relate to the ticket that I wanted to buy? It has nothing to do with it. But if you look at version B, then it becomes clear what version A is about. You bought a movie ticket to go see a movie for 200 Hong Kong dollars, and when you arrive at the cinema, you found out that it has fallen out of your pocket on the way to the cinema. Will you buy a new ticket for 200 Hong Kong dollars? And then suddenly people say, no, I can't buy this anymore because I already bought the ticket and I lost it, therefore I will not buy a new ticket. It seems like in their mind, in our minds, we tend to have accounts, different accounts, do some mental accounting where we say, okay, we are going to invest 200 Hong Kong dollars in that movie. If for some reason we didn't watch that movie and that ticket got lost, we're not going to increase that account to 400. We limited that to 200 in order to watch that movie. So we were not willing to invest in this. The first one, we have not lost anything from that account, therefore it's not related to that. It's a completely different account. But once again, we did a registered report with a replication. We've tried 22 different things that Richard Thaler reviewed in 1999. We've got an in-principle acceptance for this from something called Peer Community in Registered Report. And this was, Amy did this with me as a thesis. And you can see over here, the original findings versus the replication. So for example, here, I'll just zoom in. If lost a $10 bill, then most people are willing to buy the ticket. And well, let's go to the original one. Then most people are willing to buy the ticket, but if they lost the ticket, then it's about half-half. So switching from 88% to 46%. This is a very large effect, and this is what Richard Thaler found back in the 1990s. Then when we run the replication, it's also decreased, but not to such a large extent, from 90% to about 77%. So it does seem like there's some effects, so this is considered successful. However, in some of the replications, we also find weaker effects. But there's definitely an effect over there. So when we look at the effects in terms of impact size, we can see that for the 10 bill condition, it's about the same effect size, but in the original, there was no difference between 50-50, but in ours, there was a difference between 50-50 and 77. So we call this inconsistent, but combined together, we consider this to be a successful replication. Okay? So it seems like something taken for granted, but somehow from the 1990s until now, nobody took the time in order to replicate all of the things in Thaler. And so it's nice that we got to revisit this. And many of the things in that classic do tend to replicate quite well. So if we go to the next one, the popcorn one, what is this one about? Suppose you go into the cinema with a friend and both of you want to share a popcorn. Which of the options will you choose? Assuming that $1 US, $7.85. So this is version A and this is version B. I think almost every cinema or Starbucks or every shop, sometimes supermarkets do this all the time. This is called the decoy effect, because if you look at A and B, the large and the small are exactly the same. Where did this come from? Medium, 7. Why is this there? Why would somebody buy the medium here? They cost exactly the same as the large. So if from an economist perspective, if you have these three options, let's say that you really want to spend $7 on popcorn, you will already go for the large. So sometimes you go to a supermarket and you see one option there that actually makes absolutely no sense. Why would anybody pay that? But many times supermarkets do this, not in order to get you to buy that option. It usually has to do with what they want you to buy that's next to it to make some other option look good. So they play with this pricing a lot. This is the decoy effect. So what typically happens here? So in A, if you want a small popcorn, you go for the small popcorn. If you want a large popcorn, you go for the large popcorn. It depends on differences between people, how hungry they are, their capacity, whether they want to share, how much they want to share, and so forth. How about here? When people see this kind of thing, the medium one, which is called the decoy, kind of shifts our attention to want to buy the large one. Because when we see this, oh, the large is such a good deal. Therefore, we'll go for the large one. So we've done various replications on decoy effects. Sometimes it works, sometimes it doesn't. It's called by many different names. This is a classic effect. Dan Ariely talks about this in many different ways. But generally, with this example, it's very clear because all of us experience this when we go to the cinema, right? When you see the pricing doesn't make any sense. When we see all the venti tall and what is it in the middle, I can't even remember. Because nobody gets the grande. Nobody gets the grande. Who gets the grande? Because something about the pricing there doesn't really make a lot of sense, because the pricing is meant for you to go into either the venti, or if you really don't want that much, you forgot to the tall. So it's a really interesting kind of tactic that they do in there. Thanks for participating in all of this. We'll continue on this. If you have any questions about anything that's happening in the task, then please consult with us. Write to me on Zule. I'll see you next week.